So in our last video where we looked at redox reactions, ionic equations and redox half equations, we did a couple of simple examples. So here you can see I've got just two reactants, chlorine reacting with iodide ions. So how do we write the half equations? I chose one of the reactants and I compared, what did it become? Chlorine molecules became chloride ions. How is that possible? The molecules broke up into atoms and each gained electrons to make the chloride ions. So chlorine gained electrons, we said that's reduction. Where did the chlorine molecules get the electrons from? Well, from the other reactant, the iodide ions. Iodide ions lost their electrons and became iodine molecules. Loss of electrons is oxidation, so the iodide ions were oxidized. And if we have a look carefully, you know that if you've done the two half equations correctly, because the electrons gained in one half equation equal to the electrons lost in the other half equation. If you cross them out, you should come up with the overall ionic equation. So have a look back at the video, look at some practice worksheets that we put up to make sure that you can do these very easily before we go on to looking at how to write more complicated redox half equations. So if you have a look at this equation that I've written out, it is a redox reaction. I don't know if you can visualize why it is at the moment, but if we try to write the redox half equations, maybe you will understand why it is a redox reaction. So just two reactants again. This is how we try to write more complicated redox half equations. If you follow these simple rules, you should be okay. So I'm going to choose the lead oxide at the moment, and I see that lead oxide ended up as Pb2 plus ions, because what do I have here? Pb2 plus, Cl minus. You will see that some of the chloride ions actually are spectator ions. We'll come to that in a minute. So I write down one reactant, and what does it become? The most important change is that the lead has become Pb2 plus ions in lead chloride. But at the moment you should see this is not really balanced, because what happened to the oxygen? So rule number one, balance for oxygen with water, because this makes sense because so many reactions are taking place in aqueous solution anyway. So if I look over here, I've got two oxygens in lead oxide. So still not balanced yet, because how many oxygens do I need? I need two oxygens, so therefore I must need two water molecules. But now I've introduced something else. I've introduced a new element, hydrogen. So follow rule number two. What is this? Balance for hydrogens with H plus ions. So how many hydrogens do you have? 2 times 2 is 4. So how many hydrogen ions do I need? 4. This makes sense if you see, because in my overall equation, what have I got here? Hydrochloric acid. So there really are H plus ions in the hydrochloric acid anyway. So it's not just, balancing without making chemical sense. Now, rule number 3, you've got to add electrons somewhere. This might need a little bit of thought. So add electrons to which side? Well, let's have a look. You have to find out what is the charge on each side of my equation, because another thing that we discussed in the previous video is that charges must be on the same on both sides of the equation. So on this side of the equation, the only charge is 2 plus. On this side of the equation was the charge 4 plus. I want to make sure that the charge on both sides of the equation is the same. Electrons have a negative charge. So where will you always add electrons? You add electrons to the more positive side. So which is the more positive side? Here. How am I going to make 4 plus into 2 plus? A little bit of maths. I'm going to add electrons over here. 2 electrons. So we've just spent a little bit of time thinking about how to write the first half equation. Okay, only for this, the first half equation. It's really important that you follow the rules. Easy as 1, 2, 3 if you follow the 1, 2, 3 rules. Okay. What about the chloride ions now then? The chloride ions in the hydrochloric acid So chloride ions, remember, where did we get those from? The chloride ions are from the hydrochloric acid. Now, some of them, if you have a look, just ended up as chloride ions in the lead chloride. They didn't do any particular change. But some of the chloride ions, look what they became. Chlorine molecules, chlorine gas. So that is our redox reaction there. So what must have happened? Two chloride ions lost electrons. Let's put them over there. And that's our second redox half equation. Notice now, in this redox half equation, I didn't need to add any oxygens or hydrogens. I only follow rule number 1 and 2 if I need to. You don't just start putting oxygens and water and everything in all half equations. You only do it if you need to. Okay. So what you can do now, let's have a look here. What has happened? Cl minus was oxidized. Now, if we write down our other half equation from the previous, we can easily come back up with, so PbO2 gained electrons was reduced. So can you see how we could come up with the overall ionic equation? Remember what I want to have? I want both the electrons on both sides of the equation to be the same. So you ask yourself, are the electrons on both sides of the equation the same? Yes. So what is my overall equation going to be? Write down the reactants from both half equation. Write down the products from both half equations. So okay, I don't need to put the final electrons